Okay, so I'm going to show you how to integrate 1 over x squared times the square root of x squared plus 4. With this one, we're going to need trig substitution. We're going to need trig substitution because we have the square root of something here, we have something squared. How do we know what trig sub to use? With trig sub, we have x equals a, and then we have either tangent of theta, secant of theta, or sine of theta. We're going to let it be tangent of theta because we're adding here. So, tangent of theta. What is a? A is just going to be the square root of whatever we have in here in the number. It's 4, so it's going to be 2. Now we need the derivative, because if we're going to make the back substitution, then we need the derivative. So 2 secant squared of theta d theta. Now we can make this back substitution. We have the integral of 2 secant squared theta over, and here we're squaring x. So that's 4 tangent squared of theta. We're also squaring x here, so that's also 4 tangent squared of theta plus 4, and the d theta from here. Okay, now what do we have in here? Here we have 4 secant squared of theta. Because remember, by the trig identities, tangent squared of theta plus 1 gives you secant squared of theta. But we can factor out the 4, and so we have 4. I'm not going to write that entire thing again. We just have 4 secant squared of theta. 4 secant squared of theta. Go ahead and apply this square root. It's there for a reason. And this here becomes a 2 secant theta. The 2 cancels out with this 2. This secant theta goes away in the denominator. Rest in peace. And this one loses a secant theta. So now, what can we do to simplify? We can change it to sines and cosines. We could bring out the 1/4 in the first place. Bring out the 1/4. Change this to sines and cosines so that we can simplify stuff. This is 1 over cosine of theta. That's what secant of theta is. And here we have tangent squared of theta, but we're dividing by that. So we're multiplying by the reciprocal. The reciprocal is cosine squared of theta, sine squared of theta. Now this cosine of theta cancels out, and this one loses 1. So we're left with this. Now maybe just bring it back in reverse. Bring it in reverse and switch back to whatever these are. This is cosine over sine. What's cosine over sine? That's cotangent of theta. And we have 1 over sine of theta still left, because if we expand this, we have cosine of theta over sine of theta times 1 over sine of theta. And that is cosecant of theta. What is this? Well, this is something that we can integrate. This is just negative cosecant of theta. So this is negative 1/4 cosecant of theta plus c. But it's not our final answer, really, because we need to have x's instead of theta because we made that substitution back there. So how do we do that? The way we do that is we try to get tangent of theta by itself, because we know what tangent of theta is. It's opposite over adjacent. So we get x over 2 equals tangent of theta, opposite over adjacent in a right triangle. In a right triangle, this is theta, the angle. This is opposite, this is adjacent. But we're looking for cosecant of theta, which is hypotenuse over the opposite. Hypotenuse over the opposite. So what's the hypotenuse? That's just the square root of 4 plus x squared by the Pythagorean theorem. So we have the hypotenuse square root of 4 plus x squared over the opposite, which is x. This is theta, which we plug back into here, and that is your final answer.